Welcome to GK Tech Course. Let's dive in. One of the most important question for Java interview is why HashMap is not thread safe. Let's understand this issue step by step. Many developers think HashMap works fine everywhere, but in multi-threaded environments, HashMap is not thread safe. It leads to data corruption can happen, lost updates happen, and because of this, production failures occur. Why? Because HashMap does not provide synchronization. What is synchronization? Think of synchronization as a lock on a door. In a multi-threaded environment, it ensures that only one thread can access a specific piece of code or data at a time. Without synchronization, when multiple threads can read, write, resizing the hash table simultaneously can cause data inconsistency. We'll see this block diagram to understand the workflow. Okay, so what we discussed in this image, so there is a two threads, right? So two threads are working on the HashMap bucket, right? So when two threads simultaneously updating the data, so there will be a data inconsistency. Means there is a race condition, so two threads at a time updating the data, it may have a data inconsistency, and there will be a resize operation. So if you know how HashMap internal working, okay, so I have created a separate video on that, how HashMap internal working. It explains step by step, but it's better you need to watch that video to understand this. But basically here what will happen, so HashMap as an array of buckets. Okay, when you initialize a HashMap, it starts with a default capacity of 16 of these buckets, and it will keep the data by generating the hash code to identify the index. So when the data increases, so what it will do, it will increase the capacity from 16 buckets to 32 buckets. That time it takes every existing element and recalculates its new bucket position in the large array. That is called resize operation. Okay, so if thread 1 is resizing the internal array while thread 2 is reading, like trying to read from it, the program might crash and it return null unexpectedly or enter an infinite loop. That's why hash maps are not thread safe. Let's jump into the coding to check scenario. So here I have created a HashMap thread safety demo class, okay, and created 4 threads and doing each thread performing there is a 10,000 iteration and increasing the views count, right? Here I have created a thread, right? 4 threads I have created, and this worker thread iterating the 10,000 loops and increment the views count. And so I tried to starting that thread, right? And I'm waiting for all threads to complete. And now here what I'm expecting is I'm trying to expect the total views count. Okay, so actually it should be expected should be 40,000. Okay, and in the map, so while we are pushing that incrementing the count, okay, we have considered hash map. We have taken the hash map and we incremented the count, right? So now we'll run and see that count. So we discussed, right, hash map is not thread safe because data consistency issue, and there will be a hash table resize. Okay, so there may be a data crash will happen, so that we have discussed. So here we'll demonstrate data consistency, how it will happen. So when I'm running this application, so here expected count. So this, if you see here, we have created a 4 threads and iterating the 10,000 iteration and incrementing the count, right? So here the okay, so here if you see the output, expected count is the 40,000, right? But no, actual count, the hash map, we see that no views count will be very less. Okay, if you do this operation, so this is not constant, it will keep a different number because of the concurrency execution, right? So another time if you run, it will get in a different number. Okay, because of the race condition, so the parallel threads are running, right? So see, if you see now we got no different number, so there will be a data inconsistency using hash map, right? Hash map is not thread safe. Okay, so what is the solution now? So the solution is the production based solution is we have to use the concurrent hash map. So there will be a concurrent hash map. Okay, so which is actually thread safe because it uses synchronization, so it locks the operation. Okay, it will lock the that particular segment, it will lock. Okay, it will not lock entire table, it will lock only that particular bucket level modification. It will lock, so that this is a thread safe when multi-threaded environment. So we'll run this code. It is the same code, same, we have created a 4 threads, and each thread it is doing like iteration of 10,000 and incrementing the count. Okay, so using this compute, so we have a concurrent hash map, we will use this compute to increment the numbers, and same code it is. Okay, so and here I'm printing the expected count is the 40,000, and after pushing that data into the hash map, like concurrent hash map, and we'll reading that views count. Okay, so we'll see that output. See, now here if you see the expected count 40,000 and actual count also at received as a 40,000. So this is why we have to use the concurrent hash map for the multi-threaded environment, right? So the solution is, if you need thread safety, you have three main options. We can use hash table. So hash table, it will lock entire table actually. So it will makes the performance slow, and okay. So the better solution is concurrent hash map. So this is a modern choice. It locks only segments of the map, allowing multiple threads to work in different areas simultaneously. So in the real enterprise solution, like in payment systems, we store transaction metadata in memory. If HashMap is used with multiple threads, duplicate transaction happens and reconciliation mismatches, system failures increases. That's why enterprise system use concurrent HashMap. Important interview points you need to remember: HashMap not thread safe. Concurrent writes cause corruption. Resizing most dangerous stage. Use concurrent HashMap. If you are preparing for Java interviews, follow GK TechVerse. I explain concepts with real production example. Thanks for watching GK TechVerse. Subscribe, stay consistent, and keep upgrading your skills. See you in the next video.